end, and then you can finish that on there. And that gives you all your information. And then once your traverse is closed, it's got just the information around there. You can also have a look at the report. So any information that you've picked up in the field that you've done with your total station can then be made into a report and published directly from the software. So that makes it, again, a nice way of just sort of checking your traverse or checking your software that you've picked up in the field. Okay, so we've also got some images that were done from here, but we've had a look at that already. The other thing I also have looked at, which should be in here. Sorry, just go over this bit. So the other thing I want to show you is some of the points that were picked up in the field, picked up with the GS18. And this information, so are you familiar with the GS18 GPS? So you'll get a bit of the chat when you go out and you see the guys with the GS18. So what that does is it has an IMU in the top of the GS18, so it actually allows and will monitor and measure any tilt off vertical and take that into account and compensate for the tilt back to the vertical in the pole. This I think is actually one of the most revolutionary things that has changed surveying. In terms of, we get new equipment all the time and we go outside and have a bit of a play with it and it's like, oh, we've got new features and new bits of doing coding. But the idea that you don't have to use a bubble on the pole to check your vertical is actually amazing. It's actually one of the most critical things. And the reason as well is a couple of things. And there is a bit of an accuracy thing on the tilt. Yes, there are. The IMU still has a bit of. It still has to have sort of a standard deviation on how well the IMU works. But you don't have a bubble. Bubbles also have like a standard deviation on how well they work, and they also have to be calibrated. Who calibrates their bubbles on their poles? Some people do, but not very much. I don't know how often, the equipment here is calibrated in that sense. But the idea then that you can actually go out with a GPS and you don't have to be vertical is actually amazing. We've done a lot of work with the GS18 and looking at how it works. And because you're not having to stay still over a point and hold the bubble level, it also means that you're actually also working quicker. So you're also you're working a lot quicker, you can pick up points instantly, and we actually, instead of having a system where you would stay and maybe sort of pick up a point for a whole second and wait for your sort of GPS EPOP or update to happen for a second, there's been a lot of papers done to now say, okay, we can actually pick it up within a fraction of a second to get our result and to get our point. And you'll see that with the GS18, exactly how fast it works. But one of the things that you can do is when the data comes back into your software, you can actually have a look at that data and you can see what the tilt was applied in the field, and you can it will then give you all the standard deviations as well on all of those points. So it's a really it's a good thing to do, but it was also the traceability. With Leica equipment, it's very much, and with all of the survey equipment, you need to be thinking about not just what you're picking up there and then, how does that trace back? And I don't want to start talking about, possible legal ramifications if you guys do your jobs wrong. You don't want to be hearing that. But it's an important thing. You need to be able to not just rely on your equipment, but to think, okay, well, if I download my data, I can see all of that information. With the GS18, and if you connect it through to SmartNet, that's where you get your corrections from. That's how you get down to the centimetre sort of accuracy. Where is that data coming from? Can we see that information? When you go and have a look in the software now and you want to have a look at one of your points, I can see, what GPS systems were measured, what format I was using, which network I was using, how many stations, whether my point was actually on tilt or not. So all of that information that you collect in the field is now shown to you in the software as well. So it's really about traceability and about having that information. So it's not just a point in the field that you collect and go, right, that's a number, I've got this point. It's actually the amount of what's called like metadata as well. The amount of information which is held behind your data that you collect is actually quite critical. Moving onwards and, you know, sort of going forward with, you know, and saving that information so you know what you've got. So looked at a couple of jobs on there, and this one, as I said, we're just looking at, you know, whatever points and such that we've measured. In terms of going, you know, I mentioned about going on, what do we do with the data now? From here you can export the data into lots of different formats. XML is generally a industry standard because you can have static data, you can have collected data, you can have cloud information, you can have all that information can be stored, coordinate system information, code list information, can all be stored within the XML. Standard sort of like things like DXF or DWG that you might want to go out. It's shape files if you're going out into GIS, and again you can have all the additional, no, Andrew's just stepped out of the room, what's the GIS stuff. So you can have all the additional coding information. There's much, within the industry, coding has been used more and more now, and we're finding, so for instance with like the Westgate Tunnel project, they, instead of a surveyor going out and collecting a point and going, okay, this is, you know, the edge of this, you know, or electric cable, they now have a big form that drops down as a surveyor going, okay, who put the cable in, which company put it in, was it PowerCore, what's the size of the cable, what's the length, what's the frequency, you know, what's the wattage. So they actually have large forms to fill in, making it almost like GIS. So this sort of whole metadata which is collected within your data is part of this. I'm just doing the GIS bit. So if you want to now take your survey and export to a shapefile, it contains all of that additional information, all that metadata that you've collected in the field. Lots of different point cloud formats. A lot of these are just the point of each point cloud. We also have the intensity, so the return of the actual point cloud beam, so you can see what sort of surface you're measuring. Again, any sort of colour, image, RGB, like image coloration, so that you can recreate the point cloud using the photo. Style sheets, which are ways of manipulating the XML to make it into a different type of file. So again, anyone that's using 12D or Civil CAD or Terra Model or any of the survey packages, we can use a style sheet to export this increasingly complex data set into sometimes an import for a DOS-based survey package that's like 30 years old. You know, so you're collecting a lot of information, and a lot of the time we spend dumbing down our data back into go into like old software. So we have different ways of doing that. KML, KMZ, going out into Google Earth. We obviously work with geo-referenced images. We, you know, we looked at the drone data in the background that can be used to create geo-referenced images as well, and they can be exported. And also with, we can use on the ground, we can actually go measure an area, and then we can export that back to the drone. 3 minutes? Yeah. Okay, yep. So we can also connect to other sort of monitoring software and such from there. So that's really getting the data out. From this one, I'm just going to show you one more project. Let's do this one. So, are you familiar with the BLK 360? I don't know if Sam's got his BLK out. Has he got the BLK out?
Yeah,
Do you know?
yeah.
So the BLK is our little tiny scanner. So it's a little sort of, it's only about this big. Oh no, that project's empty, sorry. Bear with me 2 seconds. Skim that one out. And then we can get the data from the BLK, but it's, I had a couple of projects, but what I did was so the BLK was set up in a courtyard, and we took a whole image of the whole courtyard, and what I actually did was I chopped the data in half. So I chopped it in half so I could see inside, because when you're inside an area which has been scanned, you're effectively inside a lot of points. So I just sliced the data in half so I could see it a little bit better. So when you go outside and have a look with the drone, this is the BLK, this is effectively what you get. And you can actually see, and the quality is actually similar to what you get with the drone. So it's still a little bit fuzzy on some of the corners. I don't have any RTC data in here at the moment, unfortunately. I might have to try and grab some of Sam. But you can see, you know, when you actually go in, again, we're just talking about points here, but the actual definition of the corners of things is actually quite amazing of what you get. If we zoom in and zoom in and zoom in, obviously we're just looking at sort of point clouds and little coloured points on there. So, you know, when you're looking at the BLK out there, then this is the type of quality of data that you get. As I said, and this is just about half of it. I went through just in the software in here and just sliced off one side of one of the buildings because, as I said, it's difficult to navigate around with the data like that. So it's really, so the survey software these days is really not very much about just looking at total station data or just looking at GPS data. It's really about looking at all of the types of data combined. I've got about 1 minute for questions. Has anyone got any questions? Yeah?
This scan here, did you list like photos for this to get the colour?
Yeah, again, that was all done with the BLK.
Oh, okay.
Yeah, so it was all done together. But yeah, they are done with the, so the actual unit will take the photos at the same time.
And what you said here, you don't have to have the middle, the bubble.
Yeah, on the GPS,
on the GPS. How long would it take for that to be cost effective for independents or contractors to afford that? It seems a lot of